Okay, Houston, we've had a problem here.
This is Houston. Say again, please.
Houston, we've had a problem.
Houston, we don't have a problem. Today we want to talk about a concept that you probably have sort of an intuitive understanding of, and that's the concept of momentum. Momentum. What does that mean? Well, here's the definition of momentum. A measure of an object or a system's resistance to motion. So something that has high momentum versus low momentum. I'll bet you kind of, again, intuitively know this. If you've got a very large object, as in a very massive object, it will have typically high momentum because it has a high mass. But also something about its momentum has something to do with its velocity, right? So how fast something is going. So when we think about momentum, it's got two key components. Its mass and its velocity. Now, velocity, as you recall, is a vector, and so another note is that momentum is a vector. And momentum has a symbol, right? And the symbol for momentum is a funny-looking P. I think I'm just going to say it's P. The P is actually the Greek letter rho, and it is simply equal to the mass, technically by the change in the velocity, and we write an arrow over the top to indicate that it is vectoral. When we say it's vectoral, that means things can add vectorially, not just add when we're adding them, et cetera. So if I've got a momentum here and a momentum here, the actual resultant is the hypotenuse of that triangle. That's what makes it a vector. Now, if you think about what else can we talk about momentum as a way of introduction? For momentum, what units would you have for momentum? Mass is measured in kilograms, and velocity is in meters per second. So it's a kilogram meter per second. So it's resistance to change. Again, you understand this. If you have a large football player, let's say, he's a lineman on the football team, it's a lot harder to move him than it is to move a small, little, skinny runner guy, right? Let's take a long-distance runner. That's why that you put on the line in a football team, you don't look little, skinny guys. You want to resist the motion of that motion so that people cannot get to the quarterback or your running back or whatever it might be. So this is the concept of momentum, and it's resistance to change. So one other thing to note, if it's m times v, if the object is at rest, what's the momentum? And it's nothing, right? So if v is 0, then the momentum is 0. Now, you're not going to have objects that have no mass, so that's not going to apply. But it also means that I could have something that has high momentum that has low mass if the velocity is high enough. Make sense? So that's the big idea of momentum. It's not that terribly difficult to figure out. Yep, Houston, we don't have a problem.